inside the Alcubierre warp bubble. Welcome to NDJWonders, a channel under NDJProductions. Today, we're exploring a concept that feels torn straight from the pages of science fiction, yet is rooted in real physics: the Alcubierre warp drive. It is one of the few theoretical ideas that allows faster-than-light travel without breaking the known laws of relativity. And its story begins, not in the distant future, but in 1994, when a young physicist dared to imagine space itself doing the traveling for us. To understand this better, picture space not as empty silence, but as a stretchable fabric. Einstein's theory of general relativity tells us that space can bend, twist, and ripple. Gravity is simply the shape of this fabric influencing how objects move. Miguel Alcubierre realized something extraordinary. Nothing in physics says space cannot expand faster than light. The universe itself did this during cosmic inflation, so instead of pushing a spacecraft through space at impossible speeds, Alcubierre imagined bending the space around the craft. But there's more. The idea was to compress space in front of the ship and expand it behind. The craft wouldn't move inside the bubble. Instead, the bubble would carry it. From TCP's perspective, it would be standing still. From the outside, it would appear to outrun light, because relativity forbids objects from moving through space faster than light, but it does not forbid space itself from moving any speed at once. However, the real surprise comes next. To create this warp bubble, Alcubierre's equations required something nature has never confirmed: negative energy. This is not the same as ordinary energy. Negative energy would behave like the opposite of mass, pulling space apart instead of drawing it together. Quantum physics suggests tiny amounts of negative energy might appear in the vacuum between particles. But generating enough to form a warp bubble would require technology far beyond anything humanity has ever built. And yet the theory refuses to fade. Researchers continued to test the mathematics. Some found ways to reduce the energy requirements. Others explored shapes for the bubble that demand less exotic matter. A few even suggested that if negative energy exists in stable form, a warp drive might not be as impossible as once thought. Still, the challenge is colossal. Even optimistic estimates require energy equivalent to a planet. More pessimistic ones require the mass of entire stars. What happens afterward is even more fascinating. If a warp bubble could form, the rules inside it change dramatically. The ship would experience no acceleration, no crushing forces, no time dilation. It would glide effortlessly, while the bubble carries it like a wave across the ocean. Yet the edges of the bubble would behave strangely. Signals couldn't pass through normally. The front of the bubble would disconnect from the ship's ability to control it. Navigating faster than light space becomes a puzzle of physics and engineering where every solution opens a new problem. To understand this better, researchers look at cosmic phenomena that already warp space. Black holes bend it so strongly that even light cannot escape. Neutron stars twist spacetime with magnetic fields 1 trillion times stronger than Earth's. The universe itself still expands, stretching galaxies farther apart every second. These natural examples prove that space is flexible enough to produce extreme effects. The warp drive is simply an attempt to design such an effect intentionally. However, the story deepens when we consider the ethical and cosmic implications. A warp bubble might accumulate dangerous radiation at its front edge. When it stops, that energy could release in a catastrophic burst. Some models suggest the bubble could isolate its passengers entirely, making communication impossible until arrival. And other researchers warn that manipulating spacetime on such a scale could have unforeseen consequences. Not because the idea is fantasy, but because nature often hides surprises within its equations. But there's more. In recent years, small experimental results stirred curiosity. When researchers investigated certain electromagnetic configurations, they observed tiny effects that resembled predicted distortions in spacetime. These findings do not prove a warp drive is near. They do not confirm negative energy, yet they keep the question alive. They remind us that understanding the universe is an ongoing journey, and every experiment opens new territory. What happens when we place the Alcubierre idea alongside real cosmic travel is even more humbling. Our fastest spacecraft would take tens of thousands of years to reach nearby stars. Even dreams of fusion rockets or antimatter engines only reduce that to centuries. A warp bubble, if ever realized, could make the distance between stars shrink to something human lifetimes can grasp. It turns the impossible into the merely extraordinary. However, the real heart of the story is what the concept represents. It is not just a blueprint for faster travel. It is a message about imagination in science. Alcubierre did not build a ship. He wrote an equation. And that equation changed how physicists think about the boundary between fiction and possibility. Many ideas that seemed impossible once, flight, electricity, quantum mechanics, became ordinary tools. The warp drive remains theoretical, but it forces us to ask daring questions about the nature of reality. As we continue to explore the universe with better telescopes and deeper physics, we may one day learn whether negative energy can be created in usable form. We may discover new interactions in quantum fields that make warp-like effects achievable, or we may find an entirely different path to interstellar travel, inspired by the same curiosity that led Alcubierre to imagine a ship riding the waves of space. For now, the warp bubble remains one of the most beautiful ideas in modern physics, not because it promises speed, but because it challenges our assumptions. It reminds us that the cosmos is far stranger and more flexible than it appears. And it reminds us that many great discoveries begin with a single person daring to wonder, what if space itself could carry us? If you enjoyed this video, visit the links below for more content from NDJ Productions and NDJ Wonders.